As I have mentioned in the previous courses, each assembly language instruction converts directly to a corresponding machine instruction, which means that it's inherently tied to the underlying hardware, which causes the programmer to still think about which registers and memory locations they will use. And if you forgot to add an extra value or a piece of data in your code, you might have to change a lot of code to fit in it. This problem did not escape Dr. Grace Hopper. As a US naval officer, she was one of the first programmers on the Harvard Mark I computer, which we talked about in previous courses. This was a colossal electromechanical beast completed in 1944. Programs were stored and fed into the computer on punched paper tape. The Mark I's instruction set was so primitive, there weren't even jump instructions. To create code that repeated the same operation multiple times, you would literally tape the two ends of the punched tape together, creating a physical loop. In other words, programming the Mark I was kind of a nightmare. After the war, Hopper continued to work at the forefront of computing. To unleash the potential of computers, she designed a high-level programming language called Arithmetic Language Version 0, or A0 for short. Assembly languages have direct one-to-one mapping to machine instructions. But a single line of a high-level programming language might result in dozens of instructions being executed by the CPU. To perform this complex translation, Hopper built the first compiler in 1952. This is a specialized program that transforms source code written in a programming language into a low-level language like assembly or the binary machine code that the CPU can directly process.